All right, good morning, everybody. Today is Tuesday, December 16th. And today, what I want to do is I want to remind you that we are having a test tomorrow on Wednesday, December 17th. Half of the test will be multiple choice, which will be done on the Linkit platform. Okay, so half of it's going to be multiple choice with the using Linkit, in which I want to provide you a link and a test code to go in and take that part of the test. The other half of the test will be free response, which are going to be word problems, which I'm going to post onto Teams. There's one more thing that I need to review with you guys today, and that's going to be the concept of tension in the cable in an elevator. So, just as a quick reminder, when we did tension in the cable in the elevator, we were able to easily calculate the tension in the cable, which is going to be pulling upward here, if we know the acceleration and the mass of the object. G is given as 9.8. The tension in the cable will be calculated, which is in newtons, by doing mg, which is the weight, plus ma, which is what we do, which is the inertial force right there. So tension equals mg ma. If we go ahead and we look at some problems right here, nope, that's not right. Let's go undo. So the first type problem we look at is when we're not moving. That also applies to working at a constant velocity. In this case, what we have is we have a 25 kilogram lamp hanging from a rope. We want to look at the tension force being supplied by the rope. Whenever we do these problems, we have to identify M, G, and A. So the mass is given in the problem is 25 kilograms. G is equal to 9.8. And because this lamp is just hanging, it's not moving, it's not changing its velocity, the acceleration will be equal to 0. So to calculate tension is equal to mg plus ma. That's going to be equal to 25 times 9.8 plus 25 times 0. 25 times 0 is 0. 25 times 9.8. If I do that math, I get approximately 24.5. No, I'm sorry, 245 newtons will be the answer. All right, so keep on moving forward here. Let's go ahead and take a look at the next problem here. In the next problem we looked at, we are moving at a constant velocity. In this case, it doesn't say up or down, it just says moving at a constant velocity. To solve this one, we use T equals mg plus ma. The mass is given as 60. G is equal to 9.8. And the acceleration here is equal to 0. So that's going to be 60 times 9.8 plus 60 times 0. If I do the math here, 60 times 9.8 will equal 588 newtons. Okay, so you're going to have to know how to do this problem in addition to the Mini Cooper problem that we have been talking about on various days here. Let's go to the next one. If we go to the next slide, let me pause. In this problem, I have remember we had a person that's rappelling down the cliff here. Okay. And the mass of that person is 90 kilograms. We know G is equal to 9.8. Okay, and now we need to identify the acceleration. In this problem, it says the climber is rappelling from the top of the cliff with an acceleration of 1 meter per second. So that means he's going to be accelerating from the top, maybe means moving downward. So we need to make that a negative, and that's going to be -1 right there. Okay, so if I want to go ahead and calculate the tension, that's equal to mg plus ma. If we go ahead and do that, it's going to be equal to 90 times 9.8 plus 90 times -1. 90 times -1 is going to be -90. 90 times 9.8 equals 882. That, if I do the math there, tension is equal to 792 newtons. So if I'm accelerating down, the acceleration is negative. Next problem I want to work on is going to be where I accelerate upward. And let's take a quick look at that one here. And I think that this will be our last problem to review for the day. Although I do want to talk about the other type of problem, and we'll go over something like that. I'll just make up a quick problem for that. All right, let's do the last review problem. Here it says that the crane lifts a mass of 400 kilograms. We know that G is equal to 9.8. And we know that the acceleration, it's going to be accelerating upward. It's going to be positive 3 meters per second squared. Determine the tension on the crane. So the tension in the crane cable will be equal to mg plus ma, which is equal to 400 times 9.8. Then I want to do plus ma, which will be 400 times 3. 400 times 3 is 1200. 400 times 9.8, let me do that, is equal to 3920. If I do 3920 plus that original, plus the 1200, the tension in the cable is equal to 5,120 newtons. All right, excellent. So you're going to have probably one or two of these problems here. The biggest thing is going to be able to look at the acceleration and figure if the acceleration is 0, positive, or negative. If it's moving at a constant velocity, or if it's not moving at all, the acceleration is equal to 0. If it's accelerating downward, the acceleration is negative. If it's accelerating upward, the acceleration is positive. Okay, it's important to acknowledge that when I rush, if I accelerate upward, I want to see an increase in tension in the cable. If I accelerate downward, it's going to be a decrease in tension of the cable. If I'm moving at a constant velocity, up or down, or not moving at all, the tension is always equal to the weight. All right, really fast, what I want to do is I want to go over the other type of problem that we have today, which is going to be where we have to draw the free body diagram, calculate friction, calculate the net force, and calculate the acceleration of an object right there. I'm going to just go through this very quickly to be able to make sure that we're on. We've done a lot of these problems here. The first step is to, what I like to do is I like to take and look at a quick little picture of what's going on here. What I have is I have a box, and the box has a mass of 62 kilograms right there. It's being pulled across a rough surface with an applied force of 800 newtons. And we know that there is friction which acts between the surface and the box right there, which is going to be equal to 0.2. The first step is to go ahead and draw a free body diagram. Free body diagram starts with the dot, which represents the box sitting on the table. We know that it is near the surface of the earth right there. So the first question is there gravity? And there is gravity, yes. So there's a weight involved. Is it sitting on down on a surface which is going to support it? And the answer is yes. So the next force we look at, which is equal and opposite to the weight, is going to be the normal force right there. Is there some push or pull acting on this object? The answer is yes. There's what we call an applied force, and we know that that applied force is equal to 800 newtons. And last but not least, we have our final force here, which goes opposite the direction of motion, which is called the force of friction right there. Okay, first step is that's the first thing right there. Second one is going to be to calculate the force of friction. The force of friction equation is equal to mu mg, which is equal to mu is 0.2 times the mass, which is 62, times g, which is 9.8. I'm going to grab my trusty calculator here today. 0.2 times 62 times 9.8 gives me an answer. Let me check that math. 0.2 times 62 times 9.8 is equal to the math that I get is 121.52. I'm just going to round that to straight to 122 newtons. So that force of friction backward is 122 newtons. So if I look at this here and I want to do a quick evaluation right here, who wins? 800 or 122? If I do a sum of forces and try and determine what's called the net force right here, the net force is going to be the difference in the forces in the horizontal and the vertical. They cancel each other out. So it's going to be FA minus FF, which is going to be equal to 800, subtract away the 122. If I do that math, the net force is equal to 678. That's 678 newtons. Last but not least, I'm going to go ahead and I want to calculate the acceleration of this object. The acceleration of the object is equal to the net force divided by the mass. The net force was given as 678. The mass is 62. Man, I hope I can write that in there. Divided by 62. You get about an 11 meter per second squared acceleration. That's my answer, 11. All right, so we've really worked hard to try and give you enough practice to develop mastery on these types of problems. We've worked on them for several days now. They are very important. Um, I am going to provide formulas such as FF equals mu mg and FNet is equal to FA minus FF. All the acceleration is equal to FNet over mass. And also I want to provide that formula for you, which is going to be from the tension problems. I'm also going to provide you the tension is equal to mg plus ma formula for the problems that are necessary for that section on the test. At this point, I'm going to stop. I'm not going to run a live lesson today, 12/16/20, which is Wednesday. Tomorrow, before the test, I am going to run a live lesson for attendance purposes. And during the test, I will run live lessons to try and get everybody started first. If you have any questions, then what I can do is I can give you a ring back. All right. Thank you very much. Have a great day. Bye bye.